In this video, let's talk on interval notation. Now we'll talk about closed and open intervals. But let us recall, this symbol is called this symbol means greater than. This one means less than. This one means greater than or equal to. Greater than or equal to. Now this one means less than or equal to. Why this symbol means belong to or is a member of. So now we are going to talk about these symbols in details in inequalities, but for now we want to do close and open interval. So now if I say x is less than 3, now s is this symbol now means less than, so x is less than 3. So what are the numbers I can have here? S is less than 3. That means the number will start from 2 because it is less than 3. So we can say 2, 1, 0, minus 1, because the first number here is less than 3. So that means we are starting from 2. Now if I say s is less than or equal to 3, that means because it is less than or equal to, I have to include the 3. That will be 3, 2, 1, 0, minus 1. So dot 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 means it continues. Now if I say s is greater than 3, that means s is starting from 4 because it's greater than 3. That's 4, 3, 2, 1, 0, like that. Now s is greater than or equal to 3. That means s will start from 3. So anytime you have less than or equal to, you start with that number. Or greater than or equal to, you start with that number. So that means I'll start with 3, 4, 5, 6, 7. So like that. Sorry, this place s is greater than 3. That should be 4, 5, 6, 7, 8. So because s is greater than 3 and greater than or equal to, we are starting from 3. So now let's see the interval notation now. So this one is just to recall. You will learn more on that on inequalities. Now number 1, I'll start with open interval. Open interval. If a is less than x and x is less than b. Now what does this mean in interval notation? Now if a is less than x and S is less than B. So what does this implies? Now this implies this symbol means implies. Now it implies meaning A is less than X and S is less than B. Means if I want to represent this now in an interval notation, I'll write it as S is a member. So I can do it this way, use this bracket A comma B, then this, or I can write it this way, X is a member, then use this bracket A comma B, close it. Please study this notation. So that's why we are doing interval notation. Again, if I have A is less than X and S is less than B, so I can represent this in interval notation as S is a member, then I'll use this compound bracket, then A comma B, then study the pattern of the brackets, or I'll write it this way, S is a member of A comma B, but note the bracket. So this is there, meaning it is open at both ends. That's why I said open interval. So because this is less than, that means the number you have here will be less than this, and this will be less than this. That means these two numbers will not be included. It will be outside the range. So that's why it is open interval. So you remove these two. So this is how we represent open interval. S is a member, use that bracket A comma B. Now if I have, for example, let's say I have 1 is less than X and S is less than 2. So 1 is less than S and S is less than 2. What are the numbers you think you can have here? If 1 is less than X, that means the number here should be more than should be more than 1. And again, that X is less than 2. So the number here now should be like 1 point something, 1.8, 1.1, 1.2. So it will be more than this, but less than this. But we are not doing that for now. What we are doing is how to represent this in interval notation. So now to represent this using the above, I can say this is because it's an open interval. So because this is less than and this is also less than, so it's open. So now this will becomes S is a member of 1 comma 2. Take note of the brackets I'm using. So S is a member of 1 comma 2. That is the meaning of this, meaning 1 is not there, 2 is not also there. So this is how we represent, or I will say S is a member of 1 comma 2, like this. So this is how we can represent this interval. That is open interval. Take notes. So that is the first one. So now let's say we have a question. Let me give a simple example more on this one. I'm not doing equalities for now, but let me borrow it. Still on open interval. So let's say solve 2x plus 1 greater than 3. So let's solve for x. Yeah. So still like your normal equation, collect the like terms. If I'm doing inequalities, so I will explain the inequalities in details. But for now, you have idea of simple equation. So collect the like terms. this will be 2x is greater than 3 minus 1. This will be 2x is greater than 2. Then s is greater than 2 divided by 2. You know we are dividing both sides by 2. So s is 2 over 2. So x is greater than 1. And if you watch my video, I've done something on inequalities like brief, but I'll still do it again. So now we'll borrow this. So if you solve this equation, you are going to get s is greater than 1. Now, so far s is greater than 1. What are the numbers you think we can have here? It means if s is greater than 1, the numbers we can have here will be 2, 3, 4, 5, 6. You know it will continue like that. Now, what do you notice? Do you see there is no 1 here? Meaning because there is no greater than or equal to. If it is greater than or equals to, I must include 1. But since it is not greater than or equals to, so it's an open interval here. That is s is greater than 1. Now this is how we represent it in interval notation. This result, s is greater than 1. Because 1 will not be there, so it's an open interval. So I'll say s is a member of 1 comma infinity. Now infinity means you say I use open here because infinity too you can't see it, it's continue like that, and 1 also you can't see it, so it's not here. So that means I did not include 1 and this, so I'm using these two brackets to show it's not open. Now if you use this bracket and to show it's open, if you use this bracket it means it's closed. But if you use this one is open, or this one is open, this one is closed, this one is closed. But if you are using it in open interval, so you will now represent it this way, or s is a member of 1 comma infinity, as in you can also represent it this way. So you should learn the notation. So this is how we can represent this now. So that means s is greater than 1 is also s is a member of 1 to, so if I write this now, you should know it means s is greater than 1. So learn the interval notation. Now if you represent this on number line, so you will see it clearly, that is s is greater than 1. If s is greater than 1, if here is 0, you know here is 1, 2, 3, 4. Here is minus 1, minus 2, minus 3, as in like that. So if s is greater than 1, we are starting from here to go this way. So all these numbers here are greater than 1. So now because we can't continue with this 5, 6, 7, blah blah blah, so you continue with that. If you continue, you just say plus infinity, meaning it will continue like that till infinity. That's why the interval here will be s is a member of 1 to infinity, like that. So if it is this side, minus side, to be minus infinity, like that. So that is how you can represent a open interval. Now let's say another point. Please take note of the point. We are still on open interval. Now another one. Let's say at, so that you can grab what I explained in that point, at plus or minus infinity, brackets are always open. So at plus or minus infinity, brackets are always open, meaning we always use this bracket or this bracket. So it's always open. You can't use this bracket when you have infinity. So you always use this form of bracket. So at plus or minus infinity, brackets are always open. So the solution I explained now, I've already shown it on number line because s is greater than 1. So that's it. So now let's say you have a question again. Let's say we have, solve minus 2 is less than 2x minus 1 is also less than 2. So note, I'm not solving inequality here. I'm only trying to explain intervals. It's interval notation, but you can still grab something, the method I'll be using for inequalities here. So we'll still solve inequalities separate. Now from here, you can normally, this means minus 2 is less than 2x minus 1. Also 2x minus 1 is less than 2. That's the meaning of this equation. So we have two equations there. Minus 2 is less than 2x minus 1, and 2x minus 1 is less than 2. But instead of writing it separately, we can do it together. Now if we solve this together, we can have collect like times direct, meaning how can you remove this one? That is, you are adding 1 to both sides. You take this one here or take it here. So this will becomes minus 2 plus 1, as you know it's minus 1 here. So less than 2x, then less than 2 plus 1. So if I want to do it straight with one interval, so that is how I'll be doing it. So now this will be minus 2 plus 1, that will be minus 1 is less than 2x, then less than 3. So divide both sides by 2. So this is the same thing as minus 1 over 2 is less than s, and s is less than 3 over 2. Now this result, how can we represent it in interval notation? Now this is an um, less than 3 over 2. Now this is an open interval. Why? Because we have less than, we also have less than. So how can we now represent this on using equation and on graph, that is number line? Now based on the definition I gave you on open interval, this can be s is a member of, then you use this bracket. Anytime you have open, use this bracket, minus 1 comma 2, then minus 1 divided by 2 comma 3 divided by 2, then close it. Now that means this result here, we have represented in interval notation. So that means it's open at both ends. So open, meaning this one is not there, this one is not also there. Now what if we represent it on number line? This will be minus infinity, here will be plus infinity. So if the middle here is 0, so meaning all the numbers to this side are positive to plus infinity, negative to minus infinity. So if here is 1, here is 2, here is 3, here is 4, minus 1, minus 2, like that. Now we have s is minus 1 over 2 is less than s, and s is less than 3 over 2. So minus 1 over 2 is less than 1. So let's say I will locate it somewhere here. Then to this side, 3 over 2 is more than, that is 1.5. So that should be somewhere, let's say middle. So 1.5. So let's do it this way. So now this is the representation of these results on number line. So if I like, I may not use this circle. If you like, I can say, and you will notice I did not shade the circle. If I shade this circle, it means this is less than or equal to. But if I did not shade it, it means it's less than. So that's why it's open. Or I can use the bracket like this. Also like this to represent it. So that is from here to here, we represent the notation anyhow you like it. But the one we are used to is this. The one we are used to is this. So and you will not shade this because it's open and it is less than. So that's it. So that means this graph represents minus 1 half less than s, and s is less than 3 over 2. Now let's see another interval, number 2. Open, closed interval. This one is open, open interval. Number 2. Open, closed interval. So open and close interval. Now if a is less than s, so is open, is less than s, and s is less than or equal to b, that means it's closed. So if you have ordinary less than without equals to is open, less than or equal to is closed. Now how can you represent this? So this implies that it implies that x is a member. Now because it is open here, use this bracket, then a comma b, because it's closed here, you use this bracket. That means it shows that b is part of our results because it's less than or equal to. So I don't need to solve questions. I only use those questions to explain further. So let's continue with the notation. We will still solve questions to explain. Or you can say s is a member of a comma b, then you close it this way. So it's either you use any of this. So this is how you can represent open close interval. So this is it. So now let's see another one, number 3. Study the pattern. So that means if I have, let me show something. If I have 2 is less than s, and s is less than or equal to 3, that means in my notation I will say s is a member. So I will now use this bracket, then 2 comma 3. I will now use this bracket, meaning 3 is part of my interval. So if I write all the numbers here out, 2 is less than s, and s is less than or equal to 3. So that means it can be 2.1, 2.2, 2.3, 2.4, 2.9 up to 3. 3 will be there. So that's why we are using this bracket. It's closed. If you see this, you close it that way. So now let's move on. Number 3. This one is open and close interval. Then 3. Close and open interval. Number 3. Or closed, open interval. So this will be, let's say if a is less than or equal to, that is closed. If a is less than or equal to x, and s is less than, that is open. B, that is closed and open. So you should know by now, if I have less than is open, less than or equal to is closed, meaning if it is less than, the number will not be there. If it is less than or equal to, the number will be there. S is less than 3, it means s is equal to 2, 1, meaning 3 will not be there. S is less than or equal to 3, So s should be equals to 3. So I'll start from 3. So that is open and close. So when it is closed and when it is open, you use that. So I'll represent this as s is a member of, now because it's closed, I'll at the first point, so I'll use this bracket, that is a comma b, because it's open here, so I'm using this. So that's how we represent. Or you say s is a member of, use the bracket this way, a comma b, so like this. So it's either you represent it this way to show it's closed here, so it's open here, so anyhow you like it, but this is the common one you see. So now another one, this one is close open interval, so let's say closed interval. So another interval, closed interval. Number 4, closed interval. So this is, let's say if a is less than or equal to, so it's closed, x, and s is less than or equal to b, is also closed. So to represent this, we can say s is a member of, then I'll use this a comma b, then I'll use this also to show it close at both ends. So meaning if I have something like 2 is less than or equals to s is less than or equal to 4, that means I'll start with 2, then 3, 4. So that means I'm including the numbers, so they are parts. So that's how we can represent the notation. So we have 4 notations I've explained now. So the first one is number 1. I said open interval. That will be like 2 is less than s and s is less than 3. That is open interval. And you will say this is s is a member of 2 comma 3, like this. Again, I also say open close interval. That will be like 2 is less than s and s is less than or equal to 3. That means s is a member of 2, so I'm using this bracket is open, comma 3, so I'm using this is closed. Then I also say close open interval. So let's say 2 is less than or equal to s and s is less than 3. So x is a member of, so it's closed, so I'm using this. That will be 2 comma 3, then I'm using this close. Also close interval. 2 is less than or equals to s and s is less than or equal to 3. That means we say s is a member of 2 comma 3 and close it this way. So learn how to use the notation to represent question. Now let's brief question on inequalities. So in my next video, so I can start inequalities, but this video is based on how to understand the notation. So now let me just solve one question. Let's say solve 2x minus 3 divided by 4 plus 9 is greater than or equal to 3 plus 4x divided by 3. Now let's say we want to solve this question. Now do you agree that 9 is over 1? This is the same thing as 2x minus 3 divided by 4 plus 9 divided by 1 is greater than or equal to 3 divided by 1 plus 4s divided by 3. Now what is the LCM of everything here? The LCM is 12. Now multiply each. So what is the LCM of everything? That is 4 times 1 times 3, that is 12. So multiply each, as in each here, by 12. Multiply each by 12, that is plus 9 over 1 times 12, 3 over 1 times 12, 4s over 3 times 12. Now 4 here 1, 4 here 3. So this is 3 brackets 2s minus 3 plus 9 times 12. That will be 72. Now 9 times 2, 18. That is 108. 9 times 2 is 18. That is 108. Is greater than 36 plus now 3 and 1, 3 and 4, 4 times 4, 16s. Open a bracket here, that will be 6s minus 9 plus 108 is greater than 36 plus 16s. Collect the like terms. This will be 6x minus 16s, meaning take this one to the other side, is greater than 36 plus 9 minus 108. So we are taking this to also to the other side. So this will be minus 10s is greater than 63. So if we add everything here, should get is greater than 63. Because my question, so that is greater than or equals to, as in we are using greater than or equal to, so let me change that, greater than or equals to throughout. So that means we'll have minus 10 here. And anytime you are dividing by minus, we learned this on inequalities. You can watch my video on inequality. Yeah. So if you divide by negative, this symbol will change. If it is greater than, it will change to less than. And note, I just solved this straight because I'm doing notation. Just want to explain the interval. So this will be minus 63 divided by 10. Sorry, the sign will change. We are dividing by minus, it will change. That will be less than or equals to minus 63 divided by 10. So now the solution of this, if you want to represent this both number line and interval notation. Now based on what we have discussed so far, now since this is negative, that means to the negative side. And I've told you that for plus or minus infinity is always open at that point. So that means for this one now, it will be s is a member. So I'll open, then minus infinity, comma 63 over 10. So that's how you represent. But if this one is plus, for example, s will be a member of 63 over 10, meaning to plus infinity, like that. But the one we are doing is minus. So to be s is a member of minus infinity, but I'll open it here. So the bracket will be open. So to 63 over 10. But if it is on number line, so it can also be on number line. Let's say this point is 63 over 10. So just to cut it short. So everything to this place will be, so let's say this is minus. So here will be plus infinity. Here will be to minus infinity. So it will face this side. So now because it's less than or equal to, so I have to shade this point. So but what I want to note here is that we are representing it, so that means going to negative infinity. So now this is a notation, interval notation. So that means this one now is less than or equal to. Please take note of this bracket. It should not be like that. So it should be like this. So take note, because we have less than or equal to, so that means the representation there is, so is S is a member of, so it's always open at infinity minus infinity to 63. So I don't need to put minus there, so like that. Minus here. So I made wrong calculation here. The result here should be minus. So here should be minus, so that minus will cancel out minus. So we now have plus. So S will be equal to 63/10, like that. So because we have negative, yeah, as in S is less, so it will be going backward. So S is less than this, so it's going to negative side. So that will be the representation. Please take notes of this brackets we need, because it's close. So now maybe I should do more in another video. So in another video I'll do modulus or absolute value function in another video. So hope you understand this one. Thank you.